quick look at other properties. So for x greater than 0, b greater than 0, b not equal to 1. The product property, log base v of x plus log base v of y. Equivalently, we can say log base v of x times y. So in other words, product property implies that when you're adding two expressions that have the same base b in this case, that's a reference, you can combine them into a single log base of the same base and have what's inside the parentheses multiply each other. Quotient property, log base v of x minus log base v of y is equal to log base v of x divided by y. Similarly, but in division, hence the reason why it's called quotient, right? If you're subtracting and they have the same basis, you can combine what's in the parentheses with the first set of parentheses divided by the second set of parentheses, or whatever you have in the first set of parentheses divided by what's in the second set of parentheses. And this goes into a single logarithm. So change of base property. You can always use this for reference. We could have probably used this in other videos. It would have been a lot easier, but we always want to learn to do it by hand first and then try the quick way afterwards, right? It makes your life easier in the long run. Log base v of x is equivalent to saying log base a of x divided by the log a of b. So in other words, if there's a case where you don't know or don't have a base to be able to use, you can convert it into a base a of your choice. Well, what base could we use? You have two options on your calculator, right? So far, log base 10 or just log button, and the ln, natural log, which you may or may not have seen yet, agreed? So I would recommend base 10 for most case scenarios, since it's fairly straightforward. So let's try some examples. Some examples for us then. Okay, so for A, notice before we start A, we have our conversion formulas at the top of our page, agreed? Log base v of A equals C, and likewise you can convert back and forth with the exponential equivalence of b to the c equals A. So, example A, we have log of 5x plus log of x equals 4. Well, in this case, they're adding, agreed? So if we revisit real quick, previous view, when they're adding, we're looking at the product property. So when they add, you convert to a multiplication in the parentheses. So one single log though. So let's convert this into a single log. So single log with multiplication of one set of parentheses into the other. So it's 5x times x in other words. And 5x times x just gives us, well, there's two x's multiplied, right? So it's 5x squared because there's two x's multiplied. Do be aware, in this case, we cannot bring out the 2. In order to be able to bring the 2 out, the 5 must have an exponent of 2 also. That way, it's a common exponent of 2, which we can then bring outside of the parentheses. And once it's outside of the parentheses as a power, we can then bring it down. But in this case, we can't do it because the 5 does not have it. So let's be aware of that. Let's get rid of that arrow showing that we cannot bring it down for this case. Be aware of that. So let's convert it instead. Converting then. We have 10, and it's base 10, right? Because it's log. Log base 10 to the power of 4, because that's on the other side of our equal sign, equals 5x squared. That's what's inside the parentheses. And now all that remains is just to solve for x. So to solve for x, well, 10 to the power of 4 gives us 10,000, right? There's 4 zeros on 10,000, so it's 10,000. 10,000 equals 5x squared. So now let's get rid of the 5 by division. Agreed? We want to get rid of the numbers multiplied before the exponents. So divided by 5 on both sides, cancel the 5's on the right side. 10,000 divided by 5 gives us 2,000. 2,000 equals x squared. Now you can use square roots, but I recommend exponential roots, 1 over. Makes your life easier if you keep practicing them. So 2,000 to the 1/2, this becomes a calculator work. So I highly recommend you use your calculator for reference. So try on your calculator, clear anything you might have. 2,000, 1, 2, 3. Caret key now, below your clear button is your caret key. and open parentheses. If you have a T84, you may not need the parentheses because it raises it up for you. So 1 divided by 2, close your parentheses, and hit enter. And there is our answer, 44.72 roughly. So in this case, let's cancel our exponents on the right side. 2 times 1/2 cancels out, and 44.72 is our x value once we plug it in a calculator once again. So there's our result for this case. And likewise, let's go for the next case scenario or next question. B, log of x to the 9 minus 3 log of x squared equals 3. So it's a subtraction, agreed. What do we do with subtractions? Let's revisit our properties real quick. Properties for exponents. Well, quotient property looks like the one that's more useful in this case because it's subtracting. So when we're subtracting, we can divide what's in the parentheses into a single logarithm. So let's back up again to here. And we want to go for a single property. Agreed? So convert this. But before we do that, remember, a log allows us to bring an exponent up. Because otherwise we wouldn't be able to get rid of the 3. If you try dividing by 3, you still have it as 1/3 on the other log function. And you'd have 3 divided by 3 just gives you 1 on the other side of the equal sign. That's fairly easy. But it would still remain on the left side here. So instead we want to bring it up. Since it's a log, you can bring it down as a multiplication or bring it back up as an exponent. Be aware, I don't want to take the negative in this case. Now we can still see this one as a reference of subtraction. What do we do when we're subtracting? So just bringing this up, log of x to the 9 minus log of x squared raised to the power of 3. There we go. We brought the exponent, or the 3, up to an exponent, I should say. And now we want to distribute it inwards into the parentheses. So that means we have 3 times 2. Well, that would give us 6, right? So we have log of x to the 9 minus log of x to the 6 is equivalent to 3. And now we want to combine it to a single log format. Remember, we're subtracting, so it's division. So we divide on top by the first one, x to the 9. On the bottom, it's the second one that has the one that has a subtraction, x to the 6. So we have x's divided by, and it's power of 9 on top of power of 6. And just as a note, let's remember, when we're dividing, if you have the same basis, exponents subtract, agreed? So 9 minus 6 will give us 3. Once again, that's just for reference. But you're welcome to apply if you want to there on the side. 9 minus 6 gives us 3. So x to the 9 divided by x to the 6 will give us x to the 3rd. And it's a positive 3. So log of x to the 3 now equals 3. That's what remains, agreed? Okay, so let's convert. Converting from log to exponential, 10 to the power of 3 is equivalent to x to the 3rd. Notice x to the 3rd, we originally had it in parentheses, agreed? And just for reference, notice that 3, exponent of 3, comes from that equal sign. The one that's on the other side of the equal sign, I should say, 10 to the power of 3. And just visually, we can actually see the answer in this case. Otherwise, we could solve via the reciprocal or exponent reciprocal. Sort of like what we did right to the left of it, right? To the power of 1/2, but in this case, it would be power of 1/3. But we don't want to go through that much work since it's easy to see here. What is the x value equivalent? It has to be the 10, right? Because the exponent is the same. So in other words, x equals 10 is our final answer. So last but not least, we have C. C is mainly there for you to check and see that it works. It's your calculator portion of this examples. So in other words, if you had something like log base 6 of 36, if you check back, there's a chance you may have seen previous videos of mine where we did something similar, but we just did it by converting from log to exponential to make it easier to see. But in this case, now we're able to do it using our calculators, completely calculator work. Log base 6 of 36, notice the base 6 is not on your calculator, hence the reason why we convert it. And it's a base 10 that we use instead. So you take the log of the 36, the number that's in parentheses, so log of 36, close your parentheses, divided by the log of your base. Base was 6, so put a 6 and close your parentheses, and that gives you the value of 2. In other words, you have to take 6 and multiply it twice to get 36, is what we just found out. So if you notice, it works both with a calculus and without a calculus, right?